considering relationship of two quantities which are directly proportional, in which if one quantity increases, others will also increase. If one quantity decreases, others will also decrease. Or a relationship in which inversely proportional. If one quantity increases, others will decrease. If one quantity decreases, others will increase. This relationship can be represented by a linear function in which the graph is a straight line. And we have plenty of real-life experiences wherein we can associate it to the linear function. Just stick around, for in this video includes various techniques in graphing a linear function. We will also recall how are we going to graph linear inequalities so that we will fully understand how are we going to write the domain and range of a function in an interval notation. If you are new to this channel, kindly hit the subscribe button and the notification bell, and I promise that I will journey with you in learning math lessons and concepts in an easy way. Linear function. These are our objectives. After watching this video, you will be able to find the domain and range of a function, graphs and illustrate a linear function and its domain and range, table of values, intercepts, and slope. Let us recall linear inequalities so that we'll be able to know how are we going to write the solution set of an inequality, putting them in an interval notation. How to graph a solution set of the linear inequalities, how to write the solution set in an interval notation. Suppose we have this example. We are asked to graph the inequality x is greater than 3, then write the solution set in an interval notation. If we have our number line, so our boundary is 3, we will take this part and put number 3. Since the inequality is greater than 3, so we will put a hollow point here. So all values of x that are greater than 3 are values to the right of 3. So that is why we will draw a line going to the right side of 3. Another method in graphing the solution set of an inequality x greater than 3 is by using the open or close parentheses or open or close brackets. So open interval, it will be represented by an open or close parentheses, which means that the boundary is not part of the solution set. Close interval, we will be using the symbol open or close bracket, and this would mean that the boundary is included in the solution set. So in this case, we will tick this part and we will put 3, and it is open because it is greater than 3. We will draw an open parenthesis leading towards left, then we will draw a line. What is the importance of those open and close symbols in writing the solution set in an interval notation? So in an interval notation, the left part of the interval is the lower boundary, while the right part is the upper boundary. This would mean that the lower boundary, since this is open, is not part of the solution set, and the upper boundary is not part also of the solution set. If it is closed, the lower boundary is included, and the upper boundary also is included. There are times that it will be mixed. So suppose we have this number line again. So this is the inequality x is greater than 3. So definitely this is the graph. So to write this one in the rule method, it will be stated in this way. And we will read this as x is an element of a real number such that x is greater than 3. How are we going to write this one in an interval notation? Our lower boundary is 3, and this is open. Because this is also open, we just copying this symbol, then put comma, and we are leading towards right side, and it denotes, and the arrowheads denotes the infinity of the number. So number greater than 3 to infinity are part of the solution set. So that is why we will make use of the symbol infinity, and if it is infinity, we will put the symbol open. Example number 2, x is less than or equal to -1. We will tick this number line and we will put the boundary which is -1. All values that are less than -1 are values to the left of -1. Since this is less than or equal to, we will put a solid point here. and we will draw a ray leading towards left because these are values less than -1. Similarly, so we will just take this one, put -1, and we will put bracket leading opening towards left, and we will draw a ray leading towards left. In rule method, this will be stated as x is an element of a real number such that x is less than or equal to -1. In an interval notation, our lower boundary is -infinity and the upper boundary is -1. Since this is less than or equal to -1, that would mean that -1 part of the solution set, so we put bracket. Example number 3. So this is a compound inequality. This can be read as x should be greater than 1 but less than or equal to 5. So if this is our number line, so we will cut this number line into 3 parts, which means that these 2 ticks here should be the boundary, which are 1 and 5 respectively. So this one is 1, this is 5. Going to this first inequality, x greater than 1, all values that will satisfy that inequality should be at the right side of 1. And x that are less than or equal to 5, these are values that are to the left of 5. So in that case, this could be open and this would be closed. And the values of x that will satisfy this given inequality is in between 1 and 5. 1 is not included. However, 5 is part of the solution set because the symbol is less than or equal to. So in an interval notation, so we just copy this one. Our lower boundary is 1, open. Then, comma, our upper boundary, the largest possible value is 5. 5 is part of the solution, so this is closed. Example number 4. Graph the inequality x is greater than or equal to 2 or x less than -3. So in this case, we will divide also the number line into 3 parts. So this could be our boundary. So this would be the -3 at the left and +2 at the right. So values of x that are less than -3 are to the left of -3. So that is why we will put an open parenthesis leading towards left. Draw a line there. Then values of x that will satisfy this inequality greater than 2 are to the right of 2. So we'll put a bracket, draw a line. So this inequality, we will write this one into a interval notation. Our lower boundary in this first inequality is the -infinity. Then, comma, our upper boundary is -3. Union 2, our lower boundary is 2 and the upper boundary is +3. So in this case, we are putting together the possible solution of these two inequalities. So that is why we make use of the union symbol. Linear functions. We will also recall the linear equation in 2 variables. And we all knew that linear equation in 2 variables can be stated in 2 different forms. It could be in the slope-intercept form, which is y equals mx plus b. It could be a standard form, ex plus by equals c, wherein a, b, and c are real numbers. It can be stated into a slope and a point form, which is y minus y sub 1 equals m times x minus x sub 1. So the linear function y equals mx plus b, instead of using y, we use function of x. So function of x and y are just the same, in which the x is the independent variable while the y is the dependent variable. So again, x is the input, y is the output. And in the equation, m, the coefficient of x, represent the slope. There are several ways in graphing a linear function into 2 variables. It could be by table of values, second, by intercepts method, or by slope-intercepts method. So in this case, graph this function f of x equals 2x plus 5, and we ask to determine the domain and range, the slope, and the intercepts. So in this case, we will graphing this by table of values. So since our independent variable is x, we can assign any values of x here. For convenience, we will use the smaller values. For the function of x, which is the y, we will plug in what is our value of x here and determine what is the resulting value of y. So if x is negative 2, what we're going to do, we will change this x by negative 2. Same is true at the right side of the equation, we will change the x by negative 2. So f of negative 2 is equal to negative 4 plus 5, so that would be positive 1. So the function of negative 2, which is the value of y when x is negative 2, is 1. So if x is equal to negative 1, so f of negative 1, so 2 times negative 1 plus 5, so this could be positive 3. So f of negative 1 is positive 3. When x is 0, our y is 5. F of 1, so 2 times 1 is 2, plus 5 is 7. And finally, f of 2 is 9. We graph these points in the Cartesian plane. So in our Cartesian plane, so the first coordinate is negative 2 and 1. So negative 2 and 1 is here. Negative 1 and 3. Then 0 and 5. 1 and 7. 2 and 9. Connect them. So this is the graph of the function f of x equals 2x plus 5. Now the task, we are also asked to determine the domain, the range, the slope, and the y-intercept. From the y equals 3x plus 5, because we can also rewrite f of x as y equals 3x plus 5. So we will find the intercepts. The intercepts are the coordinate wherein the graph of the function crosses the x and y axis. So that would mean that our x-intercept, we are looking for the value of x when y is equal to 0. So all you have to do is just change this y to 0. This will be 0 equals 2x plus 5. Then simplify, transpose by addition property of equality, negative 5. Divide both sides by 2. So our x is negative 5 halves. The x-intercept is negative 5 halves and 0. So for the y-intercept, so this is the value of y when x is equal to 0. Or this is the point wherein the graph crosses the y-axis. You can see the graph crosses at point 0 and 5. But basically, if we are changing the value of x to 0, and from the function, we will change the value of x to 0 and solve for it. So the value of y is equal to 5. So indeed, the y-intercept is 0 and 5. For the slope, basically in the slope-intercept form, the slope is just the coefficient of the variable x. So the slope is 2. To verify, so take note the slope is rise over run. So our rise from this point, for example, is 2 units, 1, 2. Then the run is 1. So 2 over 1 is still positive 2. If the point is here, going here, so the rise is 1, 2. Then the run is positive 1. So in this case, there is no restriction as to the value of x. So the domain x such that x is an element of a real number. Since the domain is all x is a real number, the range also is a real number. So real number would mean our lower boundary is the negative infinity and our upper boundary is positive infinity. So this is one way of writing the solution set in an interval notation. That would mean the solution set are any real numbers. So graph the function f of x equals negative 2 over 3x plus 6. Then identify the domain and range, the slope, and the intercept. So in this case, we will graph the function by intercepts method. As we recall, graphing the equation into two variables by intercept method is the easiest one. This is equivalent to the function y equals negative 2 over 3x plus 6. So if we're finding for the x-intercept, we will let y to be 0 and solve for x. So this could be 0 equals negative 2/3 x plus 6. Since this is fraction, we will get rid of the fraction by multiplying the whole equation by the LCD, which is 3. So 3 times 0 is 0. Then negative 2 over 3x. So cancel out 3. So that should be negative 2x. Then 3 times 6 is 18. Transpose negative 2x to the left by addition property of equality. So this could be positive 2x equals 18. Divide both sides by 2 to solve for x. Our x is equal to 9. So the x-intercept is 9 and 0. For the y-intercept, let x be equal to 0 and solve for y. So this would be y equals negative 2/3 times 0 plus 6. 0 plus 6, our y is equal to 6. So our y-intercept is 0 and 6. Graph them in the Cartesian plane. So this is our x-intercept, 9 and 0. the y-intercept 0 and 6, connect them. So we have now the graph of the function f of x equals negative 2/3 x plus 6. So the slope is negative 2 over 3. Again, this is just the coefficient of the variable x. If you wish to verify, so our run, if you are moving the point from here to here, so our rise is negative 6 and our run is positive 9. So negative 6 over 9 is, in simplest form, is negative 2 over 3. So the domain still is a real number. So this could be written into an interval form negative infinity to positive infinity. And the range is also a real number. Graph the function f of x equals 3 over 5x minus 2. Then identify the domain and range, the slope, and the intercepts. So in this case, we will graph the function using the slope-intercepts method. In graphing linear equation into two variables by slope-intercept method, we are going to translate the equation into y equals mx plus b. So mx plus b, so this is equal to y. The slope is just the coefficient of x, so the slope is 3 over 5. And the constant negative 2 is the y-intercept. Y-intercept, that would mean that the coordinate is 0 and 2. If we have these coordinates, so take note, in graphing a line, we need at least 2 points. So we already have the coordinates 0 and 2. So what we are going to do is we will plot first the y-intercept, the 0 and negative 2. How do we find the second point? We will make use of the slope. Our slope is positive 3 and over positive 5. So from the y-intercept, we will count 3 units up our rise. So 1, 2, 3. So this could be here. And our run is positive 5. So this will be here. This will be our second point. So the coordinate is 5 and 1. Connect them. So this is the graph of the function 3 over 5x minus 2. We already have the y-intercept. We will be solving now for the x-intercept. So this would be 0 equals 3 over 5x minus 2. Get rid of the denominator, which is 5, by multiplying the LCD 5. So 5 times 0 is 0. 3 over 5x times 5 is 3x. Minus 2 times 5 is 10. So transpose negative 10 to the left to solve for x. So this would be 3x equals 10. Divide both sides by 3. Our x is equal to 10 over 3. So this is approximately here. So the domain, to negative infinity to positive infinity, and the range is also a real number, negative infinity up to positive infinity.
Thank you for finishing this video. If you learned something new today, kindly smash that like button. And in the comment section, kindly send me your thoughts about this video. Please don't forget to subscribe and share this video so that I will be able to continue to journey with you in learning math lessons in an easy way. See you in our next video. Thank you for watching.